Good. Okay, greatest common factor. So factors are numbers that you what to get another number?
Add.
Not add.
Multiply.
Multiply. So factors are numbers that you multiply to get another number. So if I have 3 times 2 equals 6, these two numbers here are called the what? The 3 and the 2 are the numbers being multiplied together, right? So what are those two numbers called?
Factors.
Factors. What's the answer called?
Factor pair.
No. This would actually, these two together would be the factor pair. The what?
It's not product.
It is product. It is product. So the answer to a multiplication problem is product. Okay, let's take a look at the next part. A factor pair is two numbers that you multiply to get a number. So a pair, think about it. Pair of shoes, how many shoes come in a pair of shoes? 2. So a factor pair is going to be two numbers that we multiply together to get a number. Okay?
You guys get made fun of if I wore rainbow Crocs to school? No.
Oh.
Are you sure?
So list the factor pairs of 24. So what we're going to do, we're going to list all the numbers that we can multiply together to get 24. Okay? I like to try to do them in order because it makes it a little bit easier. So the first factor pair that I can use to multiply together to get 24 is the easiest one. I can take 1 times 24.
Oh.
Right? Because 1 times 24 is going to give me 24. What else can I multiply together to get 24?
6 times 4.
So you want to do, well, let's do them in order. Can I take 2 times something together to get 24?
2 times 12.
2 times 12. Can I take 3 times something to get 24?
8.
What about 4?
4 times 6.
Okay, what about 5?
Nope.
What about 6? Yeah, but we've already used it, right? So once we repeat numbers, we basically have been able to find all the factor pairs. So the factor pairs of 24, so all the numbers that I can use to multiply together to get 24 are listed right there, okay? Now we're going to list the factor pairs of 36. So we're kind of do the same thing. So what two numbers can I multiply together to get 36?
1 times 6 times 6.
Well, start with your easiest one, guys. Start them in order.
1 times
Yeah, 1 times 36. What comes after 1? 2. Can I take 2 times something to get 36? If you don't know, how could you use your calculator to find that information? If you don't know 2 times what gets me to 36, what could you actually do? Yeah, divide. So what's 36 divided by 2? 18. So 2 times 18 gets me to 36. Can I take 3 times a number to get 36? We'll take 36 divided by 3. Does that work out?
12.
Yeah, so that's going to be 12. So 3 times 12 gets me to 36. Can I take 4 times a number to get me to 36? Ben? Are you thinking or are you?
I'm thinking.
Okay, sorry.
Yeah.
What?
9.
9. What about 5 times something to get me to 36?
Nope.
Nope, that doesn't work. What about 6 times something to get me to 36? Okay, so right there, I repeat my factors, right? I repeat my number. So that means I'm at my limit for my factor pairs. So there are my factor pairs for 36. Okay. So, factors of a number are always blank, then or equal to that number. So when we found the factor pairs of 36, right? The factor pairs were always, what were the numbers? They are always what or equal to the number?
Even.
Well, even would have meant like 1 times 36. Were any of the factor pairs larger than the number itself? No. So all the factors or all the numbers were always that number itself or smaller. So factors of a number are always smaller than or equal to the number. So if I ask you the factor of 36, you guys should never tell me something larger than 36 as a factor. Okay?
36.
You could say 36 because that's equal to the number, right? Okay? The next part, a blank factor, is a number that is a factor of every number in a particular group. So if we all share something, so a blank factor is a number that is a factor of every number in a particular group. So if you look at your factors of 36 and 24, well, we didn't break them down yet, so it's kind of hard, but it's going to be a common. So we're going to look for the common factor. So if we all have it in common. So a common factor is one that each group shares. Okay? Oh, Danny, you didn't grab the yellow note sheet. This is what we're writing on. Example number 3. So it says list all the common factors of 24 and 36. So if you look up above, what numbers do they have the same? What are their common factors?
1,
Okay, so they share the factor of 1. What else?
2,
What else?
3, -5.
What? Are you just making up numbers for me now? So what are the common factors? So we have 1. Well, here, let's do it this way. Do me a favor. If I have 24, tell me all the factors of 24 in order from least to greatest.
1, 2, 3, 4.
1, 2, I'm not going to put the comma in there. 1, 2, 3, 4. What else? What are the other common factors of 24? 1, 2, 3, 4,
6.
6. What else?
5.
Nope, not a 24.
No, never mind.
8.
I did that wrong.
8,
12,
12, okay.
and 24.
Okay. What are all the factors of 36? So what are all my factors of 36? What are all the numbers I can use to multiply together to get 36? 1, 2,
3,
3, okay.
4,
4, what else?
6,
6, what else?
Nothing.
9,
9, what else?
12,
12, what else?
18.
18, what else?
6. Oh no, 36.
36, okay. So now it's asking what lists all the common factors of 24 and 36. So when I say to list the common factors, it means what factors do these two numbers share? So what factor do these two numbers share? What do they have in common? What factors does 24 have in common that 36 has?
1, 2, 3, 4.
So they have 1, 2, 3. You guys said 4, 6. What else? 12. Anything else? No. So the common factors that they share are going to be one, 2, 3, 4, 6, and 12. So that's our answer for that particular question. So the factors that they both have, they have them in common. So two numbers have them in common. Okay? Have them? Just look at the numbers you circled. Okay? So greatest common factor. The greatest common factor, what do you guys think? What are my blanks?
Common factor.
Common is the largest of the greatest common factor. Factor is the largest of all the.
Variables.
So this is called the GCF. The GCF is the largest of all the common factors. You remember this now? Remember how I told you? Did I tell you guys yesterday, like, I'm not too stressed about you guys getting this because you have had this in the past. So you guys have heard of greatest common factor, GCF. It's the largest of all the factors, okay? It's the biggest number. So let's look at example number 4. Common factors. Common factors. Okay? So, looking at the list that we just came up with, where we listed all the common factors of 24 and 36, now you guys have to find the greatest common factor. So what's the largest factor that they have in common? The biggest? 12. So the GCF, oops, sorry, that's not what we want. The GCF equals 12. So that's how we would write our answer. Okay, moving right along. So finding the greatest common factor. One way to find the greatest common factor of two numbers is to list all of the, how about factor pairs of each number? You're close. Don't you guys like when you have to try to do fill in the blank? So you can list all the factor pairs of each number and then pick the blank number that is the factor of both numbers. So if you're finding the greatest or the largest, yeah. That's a really ugly S, you guys. Largest. Yeah, it's real bad, isn't it?
G-E. Why don't you like the S?
Kind of looks like an 8.
It looks like a graffiti S.
Oh, well, now I can do graffiti. That'll be my next profession. I'll be a graffiti artist. Okay. Yeah, that is very true. A lot of teachers have second jobs. Okay, so here are our steps. So when working with large numbers, so it's pretty easy to list all the factor pairs of like 6 or 8. But if I give you a number of like 1,025, you don't want to sit there and list all the factor pairs of 1,025, do you? Because that would take forever. So when we're working with larger numbers, though, it's going to be easier to follow these 3 basic steps. The first step is step 1. Write the prime factorization of each number, which makes a, do you guys remember from previous lessons and previous grades, when you had a large number and you had to find the greatest common factor, you had to make a what? What was this thing called? No? And then you pick another number. Here, let's make it easier on myself here. What's that called? Factor tree. So we're going to write the prime factorization of each number by making a factor tree. Okay? Once you have the factor tree, you're going to circle every blank that appears in both lists. So what did we do with the factors that were in? So what did we do with the factors of 12 and 36? We circled every factor that appears in both lists. Yes, so circle every factor that appears in both lists. Step 3, we're going to write out the list of the factors that appear in both lists and multiply them together, because that will then get us the greatest common factor. So when we're working with larger numbers, it's easier to do factor trees, circle the common factors, multiply the common factors that we have to get the GCF. Okay? And then multiply. We all have it? Okay, let's take a look at multiply. Example number 5. So it says, find the greatest common factor of 24 and 36 using the steps outlined above. Now you're like, Ms. Lidekin, we already know the greatest common factor is 12. I get it, but I want to be able to show you how to do a factor tree and how we could come up with 12 if we did the factor tree. So 24. Here's the great thing about factor trees. How many factors did 24 have? How many numbers can you use to multiply together to get 24? We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, right? So Jenna may use 3 times 6 to get to 3 times 8 to get to 24. Logan might say, well, I'm going to use 4 times 6 to get 24. That's fine. We don't have to use the same 2 factors to start our factor tree. So if you guys choose to use 2 different factors, you're not wrong, okay? Now, it's the end result that tells you if you're going to be right or wrong. The only factors that you can't use are the factors 1. Because what if I use the factor 1 and 24 here? I'm going to keep going down 1 and 24, 1 and 24, 1 and 24. It's never going to end. So what are 2 factors I can use to multiply together to get 24?
6 and 4.
Okay. Now, because I'm picky, I'm always going to write my smaller number first. So 6 and 4. So that means I'm going to write my smaller number 4 and then my 6.
And then you can break it down into 2 and 2 and 2 and 3.
Okay. So what Danny's saying, my tree's not done. I always call them dead end. That 4, can you factor that further? Yes. What 2 numbers can you multiply together to get 4? 2 and 2. Now, can I factor the 2? What 2 numbers can I multiply together to get 2? 2 and 1. But once I get to where the factors are 1 and the number itself, I'm done. Okay? This is called a prime number. When you have a prime number is where you have the number itself times 1. That's the only 2 factors it has. So 2 is a prime number. I'm going to circle it. It's a dead end. Well, if I know 2 is a dead end, can I factor this 2 further? Well, no, it's a prime number, so I'm going to circle it. So I'm basically circling my prime numbers. Okay, however, my factor tree is not all the way done because I come to this branch, 6. What 2 factors can I multiply together to get 6? 2 and 3, or 3 and 2. Now, can I factor 2 any further besides using the number 1? No. So there, that is a prime number. I am going to circle it. Can I factor 3? No, that is a prime number. I'm going to circle it. So right now, if you're looking at these, 24 is a composite number, meaning it has more than 2 factors. 2 and 3 are prime numbers. That's why we're circling them, prime factorization, because they only have 2 factors, the number 1 and that number itself. Okay, so now we need to factor tree 36. So we have 36. What 2 numbers can I multiply together to get 36?
8 and 8.
No, that would be 64.
6 and 6.
Okay, so we could use 6 and 6. Could I also use 4 and 9? Yeah. Could I also use 2 and 18? Yeah. So on any of those factors that you want to start with is fine. So if Danny decided he wanted to do 4 and 9, so be it. If Hannah decided she wanted to do 6 and 6, that's fine. What matters, at the end, you should all end up with the same prime numbers circled. Okay? So what are my factors for 6? 2 and 3. What kind of number is 2? Prime, so I circle it. What about for 3? It's going to be a prime number. It's going to be a dead end because it only has 2 factors, so I circle it. Well, then we already know for my other 6, the 2 factors of 6 are 2 and 3, so I circle them. Okay, so we basically just did step 1 on your notes, where it said, write the prime factorization, aka factor tree. Now, what we're going to do, we're going to make a list so that we can circle every factor that appears on both lists. Be organized, guys. So if I'm going to write 24, and I'm going to write 36. So what are my prime numbers for 24? What are the numbers I circled for 24? So those are my prime numbers. Those are what I'm going to write next to my 24. Now when you write them, I recommend that you write them in order from least to greatest. So we have 2 times 2 times 2 times 3. Now, if I would multiply these prime numbers together, what do you guys think it would get me?
Probably 24.
Yeah, get me right back up to 24. Okay? What are my prime numbers of 36? I want to put them in order from least to greatest. So my prime numbers are the numbers or the factors that I circled. So what are my factors for 36?
2 times 2 times.
And there is nothing wrong. When we have a lot of factors, you'll see me kind of go through and cross them out as I go so I don't forget any. Okay, so it said circle every factor that appears in both lists. So we're going to circle their common factors. So what do they both have in common?
2.
So they have a group of 2's in common. What else do they have in common?
2.
Another group of 2 in common. Anything else in common?
3.
So they have a group of 3 in common. Now, you could circle the group of 3 that way, or you could circle the group of 3 this way. It doesn't matter. Just circle one group of the 3's. So then we're going to drop down. We're going to put GCF for my greatest common factor. So my greatest common factor, what numbers do they have in common? What factors do they share? They share a
2 and 3.
They share a 2. They share another 2. And they share a 3. So I put the factor pair that they share, just one of them, on down. Okay? So then, do I ever leave anything not simplest form? What do you think I'm going to do with 2 times 2 times 3? Yeah, I'm going to multiply it because my last step says then multiply those factors. And when you multiply 2 times 2 times 3, what do you get? 12. So when I factored them out using a factor tree, was the greatest common factor the same as writing out my factor pairs? Yeah. Okay, flip them over. This is where we're going to have some fun. We're going to find the greatest common factor of 50 and 60. You know what I should? Usually I'm nice and I give you guys a multiplication chart already. Does anybody want a multiplication chart?
Yeah.
Okay. If you ever want a multiplication chart to kind of help you break them down real fast, they're right back here. Okay. Okay. So we're going to factor 50 and 60. So what I'm going to do, I'm going to make my first factor tree. For my 50. So start my tree. I think to myself, what 2 numbers, aka factors, what 2 numbers can I multiply together to get 50?
25 and 2.
Okay. What are 2 other factors I could use?
5 and 10.
5 and 10. Maddie, why don't you use 5 and 10?
Okay.
You feel pretty comfortable doing different numbers than me? Or do you want to use my same numbers right now?
Oh, it's up to you.
Why don't we use the same numbers right now, and then I'll show you using 5 and 10. So 2 and 25. Can I factor this 2, you guys?
Yes. No.
No. What is 2 called? A prime number. So what do I do with my prime numbers on my factor tree? For prime factorization, I circle it. That indicates to me that it is a dead end. There is nothing I can do with that 2, and I'm going to use that prime number in just a moment. Okay? Can I factor 25? Can I take 2 numbers other than 1 and 25 and multiply them together to get 25? Yeah, what?
5 and 5.
5 and 5. So 5 times 5 will get me to 25. So my tree continues to grow. I come to this first 5. I think to myself, can I take 2 numbers and multiply them together to get 5 other than 1 and 5 itself? No. So therefore, it's a prime number. Circle it. I come to this next 5. Well, we just decided, what is this 5 called? Dead end or a prime number. What do we do with our dead ends or prime numbers? We circle them. Those are going to be prime factors that we're going to use here, or prime numbers that we're going to use here in a minute. Now, you do not have to write what I'm writing in the red right now, okay? So let's say Maddie said we could use 5 and 10. So let's say that she used those numbers. Did we end up with the same numbers, prime numbers at the end? Yeah. We have a 2, 2. Do we have 2 5s? Yeah. So it's okay to start with different factors, okay? As long as you factor it correctly, you'll end up with the same prime number circled at the end. Okay, let's take a look. So now we're doing 60. What 2 numbers can I multiply together to get 60?
30.
3 and?
30. Or, wait, yeah, 3 and 10. No.
That would be 30.
30 and 2.
That would work. So I like to put my smaller numbers first. So 2 and 30. You don't have to, you guys. It's my previous students the last so many years always make fun of me because they know I will not put a larger number first because it drives me crazy. If you choose to do that, so be it. But I will always put my smaller number first. 2, what do I do to it? Circle it because it is prime, meaning it only has 2 factors, no more, meaning I cannot factor it. What about 30? Can I factor 30? 3 and 10. Or you could use 2 and 15. Or you could use 5 and 6. Does not matter. Can I factor 3?
Yes. No.
So I circle it because it is prime. Then I look at my 10. Can I factor this 10? Not 5 and 5. You're adding. And that's a common mistake. It's okay. 2 times 5. 2 is a what? So I circle it. And we already know that 5 is a prime, so we circle it. So there we just did step 1 according to our notes. Okay? So step 2 says we need to circle the factors that they have in common. Well, we can't really circle them what they have in common until we write them out in a list. So let's write them out in a list here. So I have 50. And what are my prime numbers that I circled for 50? Times.
2, 5, 5.
And now do you see how I'm writing times in between each number? That's what I expect to see on your sheet. So I expect to see the list 50, and then 2 times 5 times 5. And then what are my prime numbers that I circled for 60?
2 times 3 times, or 2 times 2 times 3 times 5.
Okay. Now it says circle the numbers or circle the factors they have in common. So what factors does both 50 and 60 have in common?
2s and 5s.
It has a 2 and it has a 5. Do they share any other number? Both of them have to have it. They have to have it in common. Yes or no?
No.
Okay, so the greatest common factor is going to equal 2 times 5. And what's 2 times 5 equal? 10. So the greatest common factor for 50 and 60 is going to be 10. Okay? Do you guys remember doing this? Yeah, okay. Now, some teachers, when they start factoring, they don't refresh on greatest common factor. I feel like it's been so long since we've had to do greatest common factor, I like to refresh on it, okay? Oh, you're welcome. I love the ones with variables. They make me happy. So example number 7. Find the greatest common factor of 20xy and 45yz. Okay, so what I recommend that you do, ignore the variables for now. Let's just factor out our numbers, okay? So we have 20, and we're going to find the greatest common factor of 20. So what are my factors I can multiply together to get 20?
5 and 4.
5 and 4. Anybody else come out with other factors?
I did 2 and 10.
That's fine. You can use those. Can I factor 4? What?
Yep.
2, 2.
Okay, and we already know that those are prime, so I circle them. Can I factor 5?
Nope.
Nope, so it's prime, so I circle it. Okay, then I come up to 45. Am I going too fast or am I okay? Okay. What two numbers can I multiply together to get 45?
9 and 5.
9 and 5, anything else? Did anybody else come up with anything else? 3 and 15? Doesn't matter. So I'm going to use 5 and 9 though. Can I factor 5?
No.
So I circle it. To show myself I'm going to use this number. Can I factor my 9?
Yep.
3 and 3.
3 and 3. Can I factor my 3?
I don't think so.
So they are prime. So I come down. So I basically just did step 1 according to my notes. So I come down. I write my factor pairs out here. So what were my factor pairs for 20?
2, 2, 5.
2 times 2 times 5 will multiply together to get me 20. What about for 45?
3 times 3 times 9.
Try that again.
Oh, 5.
Yeah, make sure you're only recording or writing down the numbers that we circled. Okay, because if you wrote that 9, that's not a prime number. So you're basically only writing your prime numbers. We're circling prime and writing our prime. So what are the factors that they share? Well, hold on. Now, let's take a look at our variables. What variables came with the 20?
X and Y.
So I'm going to put times x times y. What variables come with the 45?
Y and Z.
So times y times z. Okay. Now, All you're going to do is finish up step 2. Circle the number or the factors that they have in common. So what do they have in common here? 5 and y. So the greatest common factor would be 5y. You only take the common thing that they have. What's the thing that they share? A 5. They don't share 2 5s. They only share one group of 5s. So only the one 5 comes in. Okay? That is a common mistake, trust me. So my greatest common factor is 5y. So it's what they both have. What do they share? What do they have in common? Okay? I am going to show you another way to find what variables they have in common, because when we use variables like x to the 5th power and 7 to the 17th power, do you guys really want to write out, or excuse me, x to the 7th power and x to the 17th power, do you really want to write out 17 x's? No. So I'm going to show you a shortcut coming up here. Okay. Oh, this one's such easy low numbers here for you. So we're going to find the greatest common factor of 15 and 14. So find the greatest common factors of 15 and 14. Okay. What two numbers can I multiply together to get 15?
5 and 3.
So 3 and 5 are my factors of 15. Can I factor 3?
No.
Because it is prime, so I circle it. What about 5? Circle it. Okay. 14.
2 and 7.
Can I factor 2?
No.
Can I factor 7? No. So my factors are going to look like this. 15 is going to be 3 times 5. 14 is going to be 2 times 7. Can we circle any common factor pairs?
Nope.
No. Do they share any factors?
Nope.
They do. What does every single number share?
2.
1. So when you have something like this, and they do not share a common factor, then the greatest common factor will be 1. So the GCF equals 1. Okay? All right, let's take a look at example number 9. Oh, let's do some notes first. So it says when using variables with exponents, use the, what do you guys think we're going to use? The smallest exponent or the greatest exponent for the variable in the GCF? So if I have, let me show you what I'm talking about. If I have x to the 5th and x to the 3rd, what's the greatest common factor of x to the 5th and x to the 3rd? You have to think, how many x's do they have in common? So if I have 5 x's, I could write it out like this, right? And if I have 3 x's, I'd write it out like this. Well, to find how many they have in common, I circle them, right? How many x's do they have in common?
3.
So it's x to the 3rd. So basically, which exponent did I use there?
Cubic.
The cubic, which is the smallest. Good job. Yeah. So when using variables with exponents, use the smallest exponent for the variable in the GCF. Exponents always just messes up. They're always backwards, right? Like I'm talking about using the greatest number, the biggest number. Now I'm telling you use the smallest number. But you're trying to find the greatest number they have in common. Okay. Now let's use that information for the next example. Okay. So it says find the greatest common factor of 75x squared y cubed and 30x cubed y to the 5th. So again, I ignore the variables till the very end. And I focus just on my coefficient, the number in front of my variables. So I'm going to find the greatest common factor of 75. What two numbers can I multiply together to get 75? If you don't know, think of it like money. If you have 75 cents, how many quarters is that? If you have 75 cents, how many quarters is that? 3. And how much is quarters worth? 25. And what did you say? You said,
3, 5, and 15.
and that works too. Okay. Can I factor 3? No. So I'm going to circle it. Can I factor 25? Can I take two numbers and multiply them together to get 25? Yeah, what?
5, 5.
Yeah.
Can I factor 5? No. And then I'm going to come to 30. What two numbers can I multiply together to get 30? There's all kinds of factors, not all kinds, but there's several factors that I can use to multiply together to get 30. What are two of them? What two numbers can I multiply together to get 30? 3 and 10. Okay. What do I do next?
Back to simplify the 10 to 2 and 5.
Okay, so you're going to not simplify, but factor. And you can take 2 times 5 to get 10. Then what?
Circle
Circle what?
2 and 5.
Because they are
Prime numbers.
prime numbers. Okay. I have part of my tree branch over here that doesn't have a dead end. Can I factor my 3?
No.
No, so what do I do to that?
Circle it.
Because it's prime. Okay, so that's step 1. We basically just used our factor trees. Step 2, we're going to list our prime factors in order from least to greatest. So what are my factors of 75?
3 and 5.
5, 5.
So 3 times 5 times 5. And again, if I multiply those together, I'll get 75. What about for 30?
2 times 3 times 5.
Okay, so from here, I circle what they have in common. So what do both of these numbers share? What are their common factors?
A 3 and a 5.
A 3 and a 5. Now, it doesn't matter if I circle this 5 or this 5, as long as you circle a pair. So the greatest common factor of 75 and 30 is going to be 3 times 5. What's 3 times 5 equal?
15.
Okay, now we have to worry about the variables. Do they both have an x?
Yes.
Yes. So according to our notes, it says we're going to use the smallest exponent. So x to the second power. Do they both have a y?
Yes.
Okay, so yes, they both have a y. According to our notes, we use the one with the smallest exponent. So which exponent's smaller, to the third or to the fifth? To the third, so they share at least 3 y's. And there's your final answer.
So we don't have to write out X, X, X.
No, you do not. That would take so long to do.
Maybe I did all that work.
Did you do that? I just said I'm going to show you a shortcut, and then you just even wrote the notes down for the shortcut.
I kind of did pay attention.
Oh, Ben.
I kind of zoned out sometimes.
You know, zoning out, I get it. I do not miss going to school every day, even though I teach it every day. It's hard to be a student. Some days it is. But it is hard to sit down in a class for 55 minutes all day long. All right. Oh, my goodness. Now we have to find the greatest common factor of 3 numbers. Am I going to change anything about how I solve it? No. So basically, I'm going to do a factor tree for 36, 72, and 99. What's awesome about finding a factor tree for 36? Did we already do a factor tree for 36? Did we already factor out 36 somewhere? Yeah. What were my factors for 36? What were my prime factors for 36 that I had written out somewhere else? What were those factors that we used? What were the prime numbers that I wrote out for 36? What are those numbers that I had for 36? So I had 2, no, prime. Those are factors. You did a good job. But what are my prime numbers? Yeah. So, because I already did the factor for 36, what I would do, I'd look back at my notes or my worksheet, and I would just use and still those prime numbers instead of doing a whole other factor tree for 36, because I already did it. But I have not done a factor tree for 72, so I still have to factor that out. So what 2 factors, or what 2 numbers, can I multiply together to get 72?
Oh, I just did 2 and 36.
2 and 36. Did anybody else think of other numbers for 72?
8 and 9.
That's what I thought, 8 and 9. But it's okay. It does not matter what you start with. Can I factor 2? Riley, can I factor 2?
Sure.
Riley, I know you haven't been paying attention to this lesson. Where are you at today? Not here? Not in Miss Littleton's algebra class. 2 is a prime number, meaning it only has 2 factors, 1 and 2 itself, meaning I can only What numbers can I multiply together to get 2? Just 1 and 2, right? Meaning it only has 2 factors. It's prime. So no, we circle it. Done. 36. Can I multiply 2 numbers together to get 36? You could use 2 and 18. 2 and 12 will get you 24. Okay, we know 2 is prime, so I circle it. Can I factor 18?
No. Yes.
Yes, what?
9.
And?
2.
There we go. We know 2 is prime, so I circle it. Can I factor 9?
2 and 3.
How about 3 and 3?
Yeah, 3.
What do I do with my 3's?
Circle.
Okay. Then I come to 99. Can I factor 99?
Yes.
What is it?
9 and 11.
What else could you use? I'm going to tell you guys multiplication tables are so helpful for this. What else could you use for 99? 3 and 33. Okay. Can I factor 9?
Yeah.
What?
3 and 3.
And we circle our 3's because they are prime. Okay, so I come to my 11. Can I factor 11? Can I use 2 numbers and multiply them together to get 11? No. I could use 1 and 11, but nothing else will work. So 11 is prime. What do I do with these numbers now?
Circle.
I list them out, right? So I have 72. What are my prime numbers for 72 in order from least to greatest?
Don't forget to write 36 down.
I already got 30. 2 times what?
2 times 2 times 3 times 3.
Times 3, is that right? Okay. And then for 99.
3, 3, 11.
Okay. Anybody else's hand hurt?
Yeah.
Now, somebody had already said we circle what they have in common. So do they all share a 2?
Yes. No.
They don't all share a 2, only 2 of the 3 numbers. So they don't all have it in common. So we can't circle the 2's. Do they all share a 3?
Yep.
Okay. This is going to be real sloppy. So I'm going to do this to show my 3's. Do they all share another 3?
Yep.
I'm using different symbols to show. Do they all share an 11? No. So what's the greatest common factor? So what are the 2 factors that I identified that they shared? They share a 3 and they share a 3, which equals 3 times 3, 9. So your greatest common factor is 9. How do we feel about this? Thumbs up if you feel pretty good about it. Thumbs in the middle if we're okay about it. And thumbs down if you are hating life right now.
I did this first.
Okay. Oh, Benjamin. Last one. Ooh, you're welcome. Oh my gosh. These ones are so much fun. Don't be overwhelmed. We ignore the variables till the end, right? So ignore them till the end. So why don't we go ahead and factor our numbers, our coefficients? So I have 54. So when I factor it, I have to think, what 2 numbers can I multiply together to get 54? What 2 numbers can I multiply together to get 54? Does it end in an even number? Does 54 end in an even number? Yeah, so you know automatically it's divisible by 2. So what's 2 divided by 54?
This one?
No, if you take 54 and divide it by 2,
I feel it is the wrong one.
you did it the wrong way. Huh?
Myself.
So I have 2 and 27. What's another one I could have used?
9 times
6 and 9. Okay, what do I do with my 2? Circle. Can I factor 27?
No. Yeah.
Yeah, what? What 2 numbers can I multiply together to get 27?
13.5.
9 times 3.
How about 9 times 3? You could, but we don't want to deal with decimals. That'd be too complicated. 3 and 9. We know 3 is prime. Can I factor 9?
Yeah, 3, 3.
Okay. Then I come over to 66. What 2 numbers can I multiply together to get 66?
6 and 11.
Okay. Can I factor 6?
Yep.
What?
2 and 3.
And those are already prime. Because what about 11?
Yeah, 11.
Can we factor 11?
Oh, no.
No, it's prime, so I circle it. That wasn't bad. Even though it's a larger number, we didn't have to do a whole lot to it. Then we go on to 18. What two numbers can I multiply together to get 18?
2 and 9.
I don't want to use those. Somebody else tell me different factors for 18.
6.
3 and 6. Could you use 2 and 9?
Yep.
Yeah. Okay. What about for 6? What two numbers can you multiply together to get 6?
2 and 3.
Why do you guys always say the bigger number first? I don't understand. Okay.
So you have to put it in
I
the
say
category
overall.
to get error.
That's true. That's good. Thank you. Finally. I have an answer. Okay, what are my factors for 54? What
2
are...
times 3 times 3 times 3.
Okay. So then for 66, what are the prime numbers that I circled?
2, 3, 11.
And for 18.
2, 3, 3.
Okay. What do I do next?
Circle.
Circle what?
Common, 2
Yeah.
and 3.
Like everything they have in common. So they all have a 2, and they all have a 3. Do they all share any other number? So then my greatest common factor is what?
What about the breaks? Oh, never mind. Never mind.
2 times 3, which equals 6. Okay. Now, we have to come back up to our variables.
It would be
Okay,
A.
hold that thought. I think you're getting it. Logan, do they all share an A? Do all 3? Oh,